So in this problem, we have this series. We have to check whether this series is convergent or not. So we will try to find the pattern in this series. So if you notice first four terms, it will be difficult to find any pattern. But for the remaining terms, definitely we have the pattern. So what will we do? We will just ignore first four terms and take the remaining terms. Because in convergence of series does not affected by adding or subtracting first few terms in this series. So that is why I will ignore first four terms and take the remaining terms. So I am going to consider this series as 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial plus so on. So this series we can write in this way also, summation and starting from 1 to infinity 1 upon n plus 1 factorial. So if this series is convergent, then our original series will also convergent. So if this series is divergent, then our original series will also divergent. Now we check whether this series is convergent or not. So we will use comparison test. So for this, I am going to use one result. So I am going to use one result. So we know that n factorial greater than is equal to 2 raised to power n plus 1, where n belongs to set of natural numbers. So this result we have already studied. So I will do some modification here. So it will become n plus 1 factorial, n plus 1 factorial greater than is equal to 2 raised to power n, where n comes from set of natural numbers. Where n comes from set of natural numbers. So if you take reciprocal of both sides, our inequality will be changed. So it will become 1 upon n plus 1 factorial less than is equal to 1 upon 2 raised to power n. So here we have two series. This one is upper series and this one is lower series. So by using comparison test, if upper series is convergent, then lower series will also convergent. If upper series is convergent, if upper series is convergent, then lower series will also convergent. Will also convergent. If lower series is divergent, if lower series is divergent, then upper series will also divergent. Then upper series will also divergent. So clearly here we have, so now we take upper series to check whether this series is convergent or not. So for this I am going to take, so for this I am going to take this series as 1 upon 2 raised to power n summation and starting from 1 to infinity. So if you expand, you will have 1 upon 2 plus 1 upon 4 plus 1 upon 8 plus so on. So, so it's a geometric series because, so if you notice, it is a geometric series because if you take common ratio of any two terms, our answer will be same. So the common ratio here are r is equal to 1 by 2. So in geometric series, so in geometric series, so in geometric series, if the modulus of common ratio is less than 1, then our original series will convergent. Then our series will convergent. Let us check. So the modulus of r is equal to 1 upon 2. So it will is equal to 1 by 2, and this is less than is equal to 1. This is less than 1. So in our case, our modulus is less than 1. So by using this property, we can say that our series is convergent. So in our case, our upper series is convergent. So in our case, our upper series is convergent. So this series is convergent. So now we use this equation and we can say that if our upper series is convergent, then our lower series will also convergent. So by using this result, we can say that this series 1 upon n plus 1 factorial is convergent. By using this series, we can say that our this series is convergent, and starting from 1 to infinity. So I have already told you, if this series is convergent, if this series is convergent and this series is equal to this series. So if this series is convergent, our original series will also convergent, and if this series is divergent, our original series will also divergent. So in our case, our this series is convergent, hence we can say that our original series is convergent. Hence the solution of this series is convergent. Hence we can say that this series is convergent. This series is convergent.